Hello, this is Muhammad Mokbel, author of SPF, Shell Pcapification Framework. So today we're going to be talking about how to write a construct in SPF error language that would allow you to filter for certificates in a given pcap, looking for specific fields in the certificate. So Wireshark have added a dissector for certificates in the pcap. So earlier version or old version of Wireshark don't have such capabilities. So that's why you need to have latest version of TShark installed in order to follow along when writing this construct. We'll be also talking about some limitations in TShark, Windows, Command Shell, and SPF Shell. And we'll be talking about ways to overcome such limitations when writing the construct. So this exercise is about writing a construct that is supposed to scan a given pcap looking for specific elements in the certificate. So in this case, we're interested in malicious certificate, not any certificate, although you can generalize it to whatever kind of certificate that you're interested in. But for this purpose, I'm interested in certificate used by malware when communicating with their command and control server. So the malware could be using a legit certificate, a stolen certificate, self-signed certificate, or whatnot. To get such a list, I happened to stumble on this site called abuse.ch, and it has this list known as SSL blacklist, and it seems to be up to date. So this site contains data that goes back all the way to 2014, and as you can see here, the first entry, this was last added on November 21, 2017, so it's kind of up-to-date data. And this list contains different fields from the certificate. For example, the first entry contains the certificate SHA-1 fingerprint or thumbprint, the subject common name, and who used the certificate. So in this case, for the first entry, it would be pandas use malware family. And as you can see here, different entry or different certificate is used by different malware families. So when you write such a construct, you have to decide beforehand on what elements from the certificate you're going to be taking as your subject when testing the certificate in the pcap to consider it malicious or benign. So there are a couple of fields that this list provides us to work with. For example, it gives us the fingerprint and the common name. So if you click on the fingerprint field, you get additional information about the certificate itself. So you get, for example, the subject common name, the issuer common name, the issuer, and the fingerprint again. Right. So let's go back to the main list here. So this is that. So now we need to decide on what element to take from this list. But before doing that, you have to ask yourself, what does TShark certificate dissector provides us with to inspect any of these fields? So you can't just pick any of these fields and write your construct. Because when I attempted to do it myself first, I wanted to use the SHA-1 fingerprint field. Well, there is no such field in the certificate, because the fingerprint is the hash, the SHA-1 hash of the entire certificate itself. So it's not a field of the certificate per se. And after I completed my construct and I gathered all the data and everything, I realized that TShark display filler doesn't have the field that would allow me to inspect this fingerprint field. So I can't take that. So I thought about finding ways of enabling such a field. So one way would be to write a post dissector in Lua that would generate such a hash value and then use it in your construct. But dependability wise, it's not a good solution, so I opted not to take that solution. Instead, I've settled on the subject common name field. So the issue with the subject common name field is that it's not unique though. First of all, it's not unique per certificate, and second of all, it's very easy to abuse. By that I mean a given malware would use a legit looking subject common name, and you wouldn't be able to tell whether it is malicious or benign. However, this is the kind of data we have, and the site does not provide the certificate in its entirety in its DER format or any other format. So we have to work with what we have. So nonetheless, I settled on taking this list. So I took this list, only the common name, and then I removed all the duplicates. So this is the starting point of the list of malicious certificates with, in particular, a list of subject common names used by different malware families. So this is that for the list of malicious certificates. So as you can see here in this list, you can see it, each certificate being used by different malware family. So it might also happen that different malware families be using the same common subject name. There is no reason why not, right? So the only unique field, or I should say to a high degree in terms of uniqueness, would be the fingerprint field, because it is the hash of the entire certificate itself. So anything you change in the certificate, this field, the hash would change as well. Unfortunately, TShark dissector does not provide such a field for us to inspect from the command line. Okay, so now let us go into the actual design of the construct itself. So for that, I have the following construct that I've already written. And first I have this comment here, and then I have the following auxiliary logic definitions, and I have the rest of the logic of the construct. So the construct name is checkcert, and this is the logic. So the logic here references two AL definitions, and that's evident by the use of the insert operator, insert reference operator. It is telling you I'm referencing this AL and this AL. So what this AL contains? It contains the actual logic that would inspect the certificate in a given pcap, checking the common subject name against that list. So first, it ensures that we're dealing with an SSL handshake certificate that is being exchanged when the malware communicates with its CNC server. And then we're checking for the subject common name field here. There is no way to tell that this field is the common name field. Although here we're talking about the X509 set protocol, and this is the type of data we're looking for. However, you cannot be 100% sure that this field will be checking for the common name. Why? Because again, TShark has RDN sequence numbers, and one of the ID numbers matches with the common name. Unfortunately, you cannot use that ID number in your filter. So again, That's another limitation from TShark perspective or dissector perspective. So we have to settle on something. And here I'm using the operator matches, which technically allows you to use a regex. And here I'm using the list input operator. What this list operator allows you to do is to read data from a file on disk and inspect every element of that data inside that file one line at a time. So for every line in the file, we'll have the construct executed once. So this is that. So in case you're wondering how to use this input operator, I would recommend to go back to the documentation. It is documented on page 7, and it's very well documented. So what would this file contain, you might ask? So it would contain the list of subject common names. So as you can see already, how we're separating different elements of the construct in different fields. And this is the beauty of Eros language. So first, we have this AL definitions that contains the actual logic. And then we have another AL definition here called printout. So this definition, once we execute this construct, will print to the console the frame number, the serial number of the certificate, the country name of the certificate, and the subject common name of the certificate to the console window. So these are just display headers. And here I'm saying to display the header to the window. And if there is multiple occurrences of such match, please just display the last entry. Here, this one you can change it to F, in which it would display the first match. So yeah, so as you can tell here, I'm separating the logic from the non-logic related statements. So the inspection logic is in one AL, and the printout statement in it is in another AL, and that leaves the logic definition clean. Now let's go into the list that we're referencing in this file, the cert common name.txt, which is here. So this is how you would encode, well, between double quotes, your data in this list. So first we have this print operator. Again, please go back to the documentation to read about this operator. So this operator will print to the console the this message here that I'm giving it, telling me that the construct is currently exercising this data on this one line up to here, right? And remember, if we go back to the logic here, I'm using a regex, right? So my data here should be formatted in such a way that the regular expression engine would execute it correctly. So here, this list of data contains the list of subject common names, all separated with the OR operator. Here, as you can tell. So here, the anchor here is just to ensure that it is at the beginning of this field, at the beginning of this field, and not anywhere, so that you can alleviate some potential false positives as well. Now, as you can tell, I have more than one line. This is the first, this is the second, third. So in total, I have 8 lines. So you might ask, why 8 lines? Why didn't you just group them all in one line, right? Well, there is a reason for that. Unfortunately, Windows command shell has a limitation on the total number of characters or arguments, I should say, that you can pass when executing any program, right? So starting from Windows XP and later, you can only have about 8,200 characters in total. So I have to work with such limitations. So to work around this, I had to divide my list in such a way that would meet such a restriction. So for example, each list here contains about 7,600 characters, right? Because if you exceed the 8,200 characters, Windows Shell will just bail out. It wouldn't execute this code at all, right? That's why I had to divide it in such a way. Bear in mind that it's just like writing any other regex. You have to escape different characters. So this is what I did here as well. So we have this first list. We have another list. So the first 5 lists, they are all taken from the SSL backlist list. And here at the end, we have these 3 separate entries that I'm checking for separately, and it is for a valid reason. So this one here, it checks for google.com, right? So you can have any subdomain. Well, usually this is this is what will indicate the star sign here, right? But this is common. That's why I'm keeping it as a standalone entry, because you don't want to fire every time you execute any of those entries in your list file. So that's why it's better to give it a separate entry. And here we have the following entry, which literally checks for nothing. So you have the start anchor and the end of the string. So what this does here is literally checking for the subject common name such that it's empty. There is nothing in it, right? And this on its own is suspicious, right? So it should be treated with caution. And in the list, there happened to be a malware family known as AK Builder. So I'm not sure if this is an actual malware family. This is the builder of this AK malware family that happened to use SSL certificates with the subject common name being empty. And here, this is more like a heuristic-based type of check, where I check only for subject common names of a length between 1 and 5 characters, any characters, right? So this also should be treated with caution as well. It should be suspicious to a certain degree. Why? Because the common name should represent the name, or at least, well, because the common name should represent the host name itself, right? So if this certificate belongs to Google, so it should contain google.com. If it belongs to CNN, CNN.com, and so on. So this is that about this input list. So let's go back to the construct itself. So this is the construct again. That's about it. So let us test the construct. Okay, I'm gonna open SPF shell and let us type get all commands command, and it's gonna tell us that the construct check cert has already been verified and is available for us to use from the shell. So first, let me inspect the logic of this construct from the shell. And here it is in its final format. Okay. Let us check what pcap we have set before executing this construct. Get pcap. Okay. So we have this pcap under this name currently set. Well, I already know that this pcap doesn't contain any SSL certificate, but nonetheless, let's try the construct against it and see what we get. So I'm going to execute the construct now. And now it's running. And as you can tell, in the list file that we gave the construct, the cert common name .text, first it is printing me the list that I'm exercising against this pcap, the name of it, which this one here, and then the display headers, and if there are any matches, it would be under this header from this list, right? But as you can see here, there are none. And the same thing goes for the rest of the list. Okay, now let us go with an example with a pcap that does contain a certificate that has a match in the list file. Let us see what pcaps we have in the pcap folder. So you have the following 4 pcaps. So let me take Dridex as an example. So I'm gonna set the pcap name to Dridex. Okay, and now I'm gonna re-execute the construct against it and see what we get. Aha! So in the second list, we have a match against this subject common name, and additionally it printed the country name, the serial number in decimal, and the frame number where this common name happens to match in the pcap, and we've got no other matches in the rest of the list. So it is as simple as that. It is that clear and is that powerful. Now, what happens in case you want to test this construct against multiple pcaps all at once? So you don't have to change the pcap name from the console every time you want to test it against different pcap. So for that, you use this special file name, set pcap. You start with the start operator followed by the AF, which stands for all files, and it with the start operator. And press enter. So when you set the pcap file name to this unique file name, so what's going to happen now is that when you invoke the construct from the shell, it's going to be executed against every pcap in your pcap directory that you set from in the configuration file or from the shell. So here, if we inspect the path to the pcap from the shell, we thought get pcap path, and it's telling us it is in the current directory under the folder name pcap, right? And as I've already showed you, we already have 4 pcaps in this directory. So if I execute now the construct again, it should be executed against all the pcap in that directory. So let's test it and see what kind of matches we get. And voila. So if we go back to the beginning, so you see it here. First it's telling you I'm checking the first list in the list file against this pcap under this directory, and then the same list against this pcap, against this pcap, and against this pcap. So, and the same thing goes for the rest of the entries in the list file. And this is how it's done. So as you can tell here, in this pcap, VTSL, which is virus total SSL, I generated this one just for testing purposes. You have a match against the google.com subject common name, which is included in this list entry in the list file, right? And this is the country name, US, and this is the serial number, and this is the frame number. So bear in mind that the serial number is not unique, or at least it doesn't have to be unique actually, because you might happen to find different certificates with the same serial number. So yeah, so this is check cert construct in a nutshell. So if we go back to the constructs logic, again as a recap, this is the site from where you get this list of certificates. I shouldn't say list of certificates. The subject common name list for different malware families. And we have the following two AL logics definitions that would separate the logic from the print out statement to the console. And we have here the help file about this construct and some tag operation that you can inspect from the shell as well. So I will upload this construct to my website and provide a link for it in the description box below. That's it. I hope you enjoyed this session and you've learned something from it. In case you have any questions or concerns, please reach out to me and don't hesitate. I'm more than happy to help and provide any feedback. Have a lovely day and see you in the next session. Bye.